let's say you were given this question about rate laws and you're asked the rate law and the rate constant given this data. So we'll start by writing our rate law expression. And if you look closely, the product is also included in this data table, so we're just going to include it in our rate law as well, just in case the product does affect the rate. And this is a product. Okay, now we'll do some inspection to figure out the rate orders. So for this one, we'll look at an experiment where the concentration will change, but where the other concentrations are constant. So given that when you double the concentration of this, the rate will also double. That shows us that this M, this reaction order, is 1. Reaction order is 1. Now, what about bromine? So bromine, let's see, if we look at here where it doubles, everything else is constant. Perfect. So doubling the concentration of bromine, unfortunately, does not affect rate. So that means the reaction order is 0. That means we can just remove this from the rate law. Now, as for hydrogen plus, you can do inspection the same way, but let's just say the data they gave you didn't have somewhere where hydrogen changed in concentration and everything else was constant. Let's say that didn't happen in this case. So what you will have to do is you will need to do a calculation. So you would do a rate ratio between 2 experiments, and which experiment can be whichever, but it has to be an experiment where the concentration of the thing you have at present, it has to be changing. So whether that be products or reactants, and hydrogen plus is changing here, that means we're going to use experiment 3 and 4 for our ratio. So you can say rate 4/3, or you can say rate 3/4. It'll be the same results. And what you're going to do is just insert the rate constant, the rate law into these rates. So the rate of experiment 4 is apparently 8 times 10 to the -3, and it's the same for rate number 3. So the same thing divided by the same thing is going to be 1. And rate 4, we're going to just insert the rest of the rate law in here. Okay, and then the concentration is 1 for this one, and it's to the power of 1. And then for hydrogen plus, the concentration is 2, and we don't know the reaction order. Now for experiment 3, we also have K. The concentration of this is 2 to the power of 1, and hydrogen is to a concentration of 1 to the power of something. Now we can cancel out K, and what we can do is we look at this, so then we say there is 0.5, and then we look at this, so we can say there is 2 divided by 1, that's 2 to the power of x. So 1 divided by half is 2. So that shows us that x must be equal to 1. So this would be the reaction order for hydrogen. And luckily with this table we can check actually. So this is a part where hydrogen ion doubles and everything else. Oh, actually, yeah, you couldn't check with this table either. So perfect. That's why we do these calculations. 1. And now we're going to find the rate constant, which is K. Okay. So with our new rate law, so power of 1, you can just omit the 1. So we're going to find K. Now, here we have an overall reaction order of 2. That means when you get your units for K, it will be something that corresponds with an overall reaction order of 2. Even though both of these are individual reaction order of 1, the K is going to be the units for the overall reaction order. Okay, so then we have to isolate for K. And which rate are we going to use? Well, we can use any rate provided that you're just sticking with one experiment. So let's use experiment 1. Actually, let's do experiment 2 because 1 is pretty obvious. It's just going to be 4. Okay, experiment 2 it is. So the rate at experiment 2 is 8 times 10 to the negative 3. And that is mole per liters times seconds divided by the concentration of the first thing we have and the second thing we have. And they're both exponent 1s, which is easy. So this is just 8 times 10 to the negative 3 divided by 2. And the units, let's see, mole per liter. I made another video on finding out the units for the K. That's pretty more comprehensive. So here I'll just jump to the gun, get to the easy stuff. So the answer is going to be and that will be the rate constant.